Hello dear students, today I will discuss about Runge's method and Runge-Kutta method. Okay, the Runge's method, just in the previous class we have already discussed about some numerical methods, Euler's methods, Euler modified methods. Here Runge-Kutta methods. Before that, Runge's method. What is Runge's methods? So here, just remember that if we are having differential equation, first order differential equation is equals to like this, fxy, and given condition is y equals to y0 and x equals to x0. This is initial value problem. Initial condition is this and differential equation is this. We have to find the value of y for a particular value of x. Starting from here, just see if this is our x-axis and y-axis. Okay, we know the solution of this differential equation is a relation between y and x, the value of y in terms of x. Just after applying this by analytical method, we can find the solution. After finding constant from this condition, we can get, and after that we can find the value of y for any value of x. But in many situations, the format of fxy are of different types. So every time we cannot apply ordinary method or analytical method. So here numerical method is very important. So in this situation, suppose we are giving this condition, that is the value of y is given value at for the value of x0. This is initial condition. So suppose this is point P, and one thing remember that solution of this equation is a relation between y and x, the function of x, y equal to function of x. We can draw the graph of that function, that is curve. We can get a curve for the solution, that is the curve of the solution. If suppose this is curve of the solution, suppose this is curve of the solution. Curve of the solution means, curve means what? Y equals to function of x. This is solution, suppose. Then it can be drawn graphically. We can get a curve. Suppose this is the curve. Clear? And this is initial condition. That means this point will satisfy this curve. That is, this point is on this curve. That is P on this curve. Okay. So this value is what? This is value of x, x0, and this value is y0. This value is y0. Clear? Now, for a particular value of x, suppose x n xn maybe in this side. Okay, just x1 may be anywhere. So just if initial value is this and targeted value for which we have to find the value of y, if here, then this interval, if this interval is small interval, then we can do one time process and we can get the value for y at the point x equals to xn. Just like suppose this is 1, 0, this is 0.2. And for x equals to 0, we are given as initial condition and we have to find the value for x equals to 0.2. This is our target. Then this is single interval and its length will be what? 0.2 minus 0, 0.2. It can be taken as a small length interval. So we can do single process. If this interval is big interval, and then we can divide this interval and we can do the same process in first interval, in second interval, in third, in fourth, and so on. As suppose we are giving first value of, for the value of x equals to 0, we are giving the value y0. And we have to find the y for 0.8. And then we can divide it as a taking small length interval 0.2 or also 0.1, but 0.1 is very small, so 0.2. So 0.2 means 0.2, this is 0.2, this will be 0.4, this will be 0.6, this will be 0.8. Okay, so 1, 2, 3, 4, 5. Four intervals are there. So in that case, we can do same process for this and then this, for this and for this. So here just we are trying to understand what will be the formula in one subinterval, first subinterval. So the same process will carry for the next interval. For first interval, our initial value will be x0, y0. For the next interval, just in first subinterval, the values which we have already find by one time process, that will be used for starting value for the next interval. So first interval, how can we get formula for first interval? Okay, so here this is our initial condition, so this point will be on the curve. Now suppose its name is L, that is x equals to here x0, that is this length is from here, this is what? x0. And next, if this is curve of solution, then next value for, suppose here is this. If this is actual curve, then this is PQ curve and Q, that will be the actual value, but we have to find numerically by taking some process. So here suppose this is M and our first interval, this is our first interval L, M, and if we take interval length as H, then this value is x0, or this value is what? X equal to x0 plus h. Okay, h interval length. Here just we have to approach this curve. We have only this value. Okay, so draw here tangent. Just first of all we have to take midpoint of this ln, midpoint of ln. That is, this length is h by 2. This is midpoint. This is midpoint. Suppose midpoint. This is n. What? This is n. Lm. N is the midpoint. Clear? Now, ordinate through this ordinate through n will be this perpendicular line. Touch here at point S. Suppose this is original value. Just at present we know only x0, y0. Okay? We take this interval. Our first targeted value is this. In this interval we take middle point here and draw ordinates. Now we can draw tangents at this point. This is tangent. This is tangent at point P. Okay? With slope. This is line touching here. If this is curve, then slope of tangent is given by which value? If we draw, this is parallel line to x-axis. Okay, suppose this is R point and this is S1, this is S1, this is H, and this is T. This point is T. This point is T here. Here, this point is R. Just we draw parallel line and tangent at P, this with slope. We know if this is curve, slope of tangent at this point, what? Dy by dx at P. Dy by dx at P. Here dy by dx equal to this. So dy by dx at P, x0 y0 means P means this, x0 y0, P means x0 y0. So slope at here, slope, what will be the slope? fxy, fx0 y0. Okay, so here we have to find the value of, in this interval, just for this point we have to find yq. This is y0 at this point. This is yq at this point. This is the value of y ordinate at this point. This is our targeted value. Maybe this point, this value is 0.1, this value is 0.2. 0.2 is our targeted value. This is given. So for this we have to find the value yq. Yq will be our targeted value for finding for this equation. So from here, suppose this is angle theta. This is angle theta. Clear? Then from here, just we have to find the value of what? Suppose this ordinate touch here y at S, and this is tangent intersect at S1. This is S, ys, the value ys at this middle point. At this middle point means what? Here x equals to x0 plus half h, because half h or this full h. Just ys is the value of y at x0 plus half h. This value is approximated by our tangent, because curve is approximated. Just here we approximate this curve by using tangent at the point P. Okay, so the ys is given by this ys1 and s1. Clear? So here this is y0, this is also y0, this is also y0 up to this. Okay, so this is very clear because this is parallel line, this is parallel line. So this is our extra value. For this actual value of y at this point, this is y0 plus this, y0 plus this at this point. Okay, so here we have to find the value ys, and here y. Just here what we have to do, just see, y s is given by how? Ys equals to n s1, because this is tangent. By this tangent we have to approximate to the curve, so ys is given by n s1, n s1 equals to nh plus h s1. Okay, here ys means this value is given by, just very clear, n s1, and n s1 means n h plus h s1, and we can get, if this is theta, then slope is tan theta of this tangent. If slope is tan theta, that is, in this triangle we can see that h s1 equals to ph into tan theta. nh, here nh means lp, we can write nh means lp plus h s1 means perpendicular base equal to tan theta, so ph tan theta, that is lp means what? y0, this is also same value, so y0 plus ph means what? ph, this value h by 2, as h by 2, and tan theta, slope f x0 y0. Okay, so we can write here f x0 y0, slope at the point p x0 y0, p is point x0 y0, so here slope is this from our differential equation, so ys equals to this. Clear? So ys equals to y0 plus half h. This is our first note down list. Okay, now here we have to find next value as yt this. Okay, and then we have to find, just we have to draw a line here. First of all, just find the value of yt. Also yt means this value. So yt equals to mt mr plus rt, mr plus rt, mr plus rt, very clear, mr plus rt. So mr plus rt, mr means lp, just clear from here, rt means what? This, rt means this, so rt equals to, also we can write pr tan theta, just from this triangle, pr base, this is perpendicular, so pr tan theta, so we can write pr tan theta. So just write LP means what? Y0 plus PR means this to this. What? H. PR. This is value H. Tan theta, that is slope. That is F, X0, Y0. Slope at this point. Clear? So just this is YT. Okay. Now we have to find our final targeted value, the end point of this interval. This, because just we divide this interval into parts by taking midpoint. So here this is our targeted value. So here for best approximation, what will be the value? YQ. So now YQ equals to what? YQ is given by, suppose this is the ordinate line from this point. Now we have to approximate this curve by the tangent, just dividing this interval and tangent this to this to this to this. That means in the next, just in this step, we have to take or draw a line through point P. If by this tangent we have to approximate curve, then at this point we can find slope. At this point the value of slope is used for drawing a straight line passing through the point P. Here slope, just if this point is on the curve, then at this point we can find the slope of the tangent of slope at this point to the curve. Suppose at this point slope is, at this point how can we draw the slope? By this line, or we have to draw a line with this slope through P, just like this. This is our T dash. Here what we do? Just if this point is approximated, the curve is approximated by this tangent, then this point is on the curve. Now suppose at this point we have to find slope, then we can find, so just like at P, slope is what? This. Fx0, y0. At this point also we can find slope. Suppose this angle is this horizontal line, this angle is theta 1. This angle is what? Theta 1. This angle is what? What will be the angle? Theta 1. This angle. Complete. This big triangle. Because this line is parallel to this line, its slope at this point, if theta 1, this is also theta 1. So in this triangle, because this line suppose intersect ordinate through this point Q, this is our error point. If our line is intersecting here, then actual value we can get. But maybe this ordinate intersected with this line at TU dash, then this is our error point. So our value YQ is given by M T dash. Okay, so YQ equals to We have to find yq. Yq, this is our actual value at this point. But yq is given by mt dash. That is mr plus rt dash. This, in this triangle, we see that prt dash. We can find slope. This slope of this line and this line is same because this line is parallel to this. Just we draw this line by taking slope of this line here. So here yq equals to our targeted value. Yq equals to what? mt dash. That is mt dash means we can write mr plus rt dash. That is what? mr means lp plus rt dash. rt dash is equals to this perpendicular, this is base, this theta 1. So slope at this point, what? Slope at this point, PR tan theta 1. PR tan theta 1. Okay, so this is y0 LP. LP is y0. Same MR LP. And PR is what? This H. And tan theta 1, this slope. At the point this, and slope is given by fxy dy by dx. At the point x0 plus h. x0 plus h. F of x0 plus h y t, because tan theta 1 slope at t, that is yt. Yt is this. So here we have to write what? Yt. Slope. This is slope. Value of x is x0 plus h and y is this at t. Slope at t. So yt. So this can be written as what? y0 plus h and value of yt is this. In terms of x0, y0. Okay. So f of x0 plus h, y0 plus h, fx0, y0. So this is yq. This is yq. So here three values are, we have at this point yp, at this point ys, at this point y. So this three value, what? Value of the slope at p, value of the slope at s, the value of the slope at q, just we get. Okay, so this, by using this values, we can find a formula from this differential equation. Just here note down what ys is this. Here we see that slope of, this is the value of yq, this is the value of ys. Just we can see that here y0 plus h, half h this. Here y0 plus h of this. Clear? This and also yp here y0. Okay. So now from this diagram we can say that the value of fxy, that means what? Slope fxy, this slope at p is equals to here what? fx0 y0. Similarly, value of fxy, that means what? Slope at s. S is also on the curve. Just we have to approximate this by this tangent. So what? Ys. This value at this what? F x0 plus half h and here ys. x0 plus half h ys. Slope. The value of f xy at q at this point, q at these three are what? x0 plus h y q, and yq is given by this because all values are known values. So we can find the value of yq, we can find the value of ys. Just you have to put here. It is known, yq is known, and this is from differential equation. You can use this format for finding value of this. Just we can find the value of all these values, that is all this slope at here, at here, at here. These are the useful for formula. Okay, here just ys, yq all are given from this formula, from this formula. From this formula we can find the value because this is differential equation, and this differential equation is given, that is function fxy, value of function fxy where we will given in the question. From this format we can find the value of this, that is ys, because this is given, this is given, this is given, h is also we know. So we can find ys. If we can find ys, so ys is used here, and it is also known. So f of this can also be found from this fxy format. Similarly, yq can be found. All are known values. Okay. So all the values of fxy, that is slope at the 3 points, are used in formula. How? So see, this formula will be used. Okay, formula. What will be the formula for finding the approximation of y at the point x equal to x 0 plus h? So see here, how can we find the formula? By using Simpson's formula. Simpson's formula, you know, for integration. Okay, just we have to integrate this given differential equation. This given differential equation we have to integrate now. Okay, on both sides, just from this point to this point. This point means what? x0, y0. This point means what? x0 plus h, y0 plus k. We can say that y0 plus h, x0 plus h, and the value of y. What will be the value of y? Here y0 And here x0 plus h, and value of y will be what? y0 plus k. That means here point will be what? x0 plus h, y0 plus k. K is the increment. This k0 is the increment. Sorry, k. We have to try to find the value of k and purify the value of k. Clear? So here x0, y0. Here x0 plus h, y0 plus k. Increment in x, h. Corresponding increment in y, k. So this point will be what? x0 plus h, y0 plus k. K is the increment in y. Our target is finding this value. Just purify this value step by step. Okay, here in first step, in first interval, just for finding value of k, integrate this equation on both sides. Just y0 to y0 plus k dy by dx equals to x0 to x0 plus h fxy dx. Integrate on both sides. x0 y0 to x0 plus h y0 plus k. This point to this point, just we have to integrate. Integration from here to here. Clear? So here we get what? y0 plus k. Here y. Put this limit y0 plus k minus y0 means k. This is our increment in y. This is our main target. If we can get the value of k, then our value or solution will be the value of y, that is approximation of y, that is y1 for first interval, y1 equals to y0 plus k. This is x0 y0, x1 y1. x1 means x0 plus h, y1 means y0 plus k. K is the target. So now we will try to find the value of k. So this is equals to here by using Simpson's rule. Simpson's integration, numerical integration, differentiation. Also you have already studied about Simpson's rule. So here just in this three step, first, second, third. So x0, x1, x2. Okay. So here by using Simpson's rule, we can get its value as 1 by 6 h, the value of what? These values. F, value of this function f at this value, because integration of this here f p first point and second 4 times of f at s plus f at q using Simpson's rule in first subinterval. We will get like this. Clear? So from here we can get formula. Just write this all the way. This means what? So this is our formula. What k is equals to 1 by 6 h. Fp means what? Fx0 y0 plus 4 times of Fs means this f x0 plus half h y s plus f x0 plus h y Q. So this is our formula for finding K. Okay. Now it can be simplified by a set of formula, because our target is what? Increment in y. We have to find. Okay, so this is the increment. And it can be written also like this: 1 by 6 h fx0 y0 h fx0 multiplied by this h. Okay, so here 4 h fx 0 plus h by 2 ys and plus h f x0 plus h y q, and this yq and ys are given by just we have already find it. Okay, now it can be simplified by a set of formula k1 k2 k3 and finally k. K is the weighted value for this 3 point. Okay, so here formula can be written for Runge's method just like this. We have to calculate all the values. At first value is what? Here we see that this. So we have to calculate successively. We have to calculate, this is the method. We have to calculate successively first this value k1 equals to h f x0 y0. We can find it because the format of this is given, x0 y0 is given. Just use that format and use the value, given value, and h equals to we know 0.1, 0.2, 0.3, maybe anything. So we can find the value of this. Now find k2. The value k2 can be found just if we find this value. In the previous formula you can see that h f x0 plus h by 2 here and here ys. The value of ys was what? Value of ys what was y0 was the value y0 plus half this. So we can write y0 plus half of this. So half of k1 we can write k1 successively, because just you can see in the previous page what was the value of ys. y0 plus h by 2 fx0 y0, that is y0 plus 1 by 2 h fx0 y0. So k1. So this k1 may be used here. So here we can find this value by using this k1. So by using this format we can get the value of k2. Clear? Now k3. k3 equals to, k3 can be found by using fx0 h into x0 plus h x0 plus h yq. The value of yq was what? y0 plus y0 plus, here long value is given just like h of fx0 plus h y0 plus h fx0 y0. It can be find through another formula x0 plus h y0 plus k1, because it can be simplified with another value, that is k dash. Just write k dash, where k dash equals to, because you can see in the previous page that the value of yq is right as a what is was right, y0 plus h f x0 plus h y0 plus h f x0 plus h y0 plus h fx0 y0, that is, this is k1. So y0 plus k1, so it can be written like this, y0 plus k1. Good. What? This is equals to h f x0 plus h y0 plus k1. Just remember it. So this is k1, k2, k3. Because this is, in place of this, we write what as a k1. This is what? K2. This is what? K3. For this writing K3, YQ is simplified by K dash. K dash is equals to this. H fx0 plus h y0 plus k1. x0 plus h y0 plus k1. Okay. So this is k1, k2, k3. Okay. So final increment. Finally, we have to calculate successively this, and then finally compute the value of k as follows. K equals to this. K equals to 1 by 6, first value k1 plus 4 k2 plus k3, just this. Okay, so this is our formula for Runge's method. Okay, when we got the value of k, then we can write our solution as a y0 plus k, the value of y. Okay. After finding the value of k, we can write by using this increment value of increment value of k in y, increment value of k in y we can get the required approximation of y, approximation of y as y1 equals to y0 plus k equals to y0 plus k. That means put the value. And this will be the solution at x0 plus h. Here, at this point, the approximation of y will be given by y1 equals to y0 plus k. y0 is given and k is this. So, Runge's method formula is this. These are the Runge's formulas for Runge's method. Clear? What we have to do? First of all, this is our given differential equation. Just write the format of this. Maybe fxy equals to x plus y square, x plus y to the power x, anything. So format is this, we know. Now, we have to find successively. First of all, we have to decide what is the value of x0, what is the value of y0, and what is the value of h. What is the value of h? Interval length, side interval length. Okay, so these three things we have to decide first, and format is given in the equation. And then just start the finding value k1, h fx0 y0, k2 fx0 y0. If we put here, then by this format we can get the value by using this. Now for k2, h fx0 plus h by 2 and y0 plus half k1, the value which we have got in the previous step. So just use this value of k here, and finally find the value by using this format. And for k3, first of all find k dash by using this. Here k1 first value is used here. Okay, and x0 plus h, use the value of x0 and h and y0 and k1, and find the value of this by using this format, and to h, that will be the value of k dash, and this k dash is used here, and then again we can find the value of k3. After getting these three values, we have to compute the value of k finally. K equals to this, k1 plus 4, k2 plus k3, just calculate, that is the value of k, and just this value is added to the y0. That will be our first approximation for targeted at the point of this end point. This will be our solution. Clear? So this is the Runge's method formula. Okay, just we have to remember this, and final answer will be this. Just our formula is what? This, and this, and Runge's method. Clear? So take a questions related to Runge's method. Okay, this formula will be used for finding solution. Okay. Runge's method, and just after this questions we have to discuss about Runge-Kutta method. Runge-Kutta method is also just like similar process, but first of all we have to take the questions. Just apply Runge. Apply Runge's method to find an approximate value of y when x equals to 0.2, given that dy by dx equal to x plus y and y equals to 1 on x equals to 0. So very simple questions. Main thing is that here formula you have to remember. Okay, So formula should be very clear, because by using formula and you have to use calculator for getting the value. Okay, here you can get the result in single step or maybe in 2, 3, 4 stages, because suppose we are given for finding the value of y at 2, 3 points and taking some step. If some step is there, so single step in single interval, single process we will do. If there are 3, 4 steps, the 3, 4 sub interval, then we have to do same process for first interval, and then by using values of first process as a first value for the second interval, just we have to do. Here question is what? Given differential equation is solution just like this. Given dy upon dx equals to x plus y, x plus y, y equals to 1, x equals to 0, y equals to 1 when x equals to 0, and we have to compute, we have to approximate the value of y when x equals to 0.2, x equals to 0.2. Here step is not given, that is a value of h is not given. So see here, this type of questions you can get. Okay, so here this is differential equation, this is initial value problem. We have to find the value of y when x equal to 0.2. And here what is given? y0 equals to 1. That is when x equals to 0, then y equals to 1. That means this. Here we have to find the value what? Y 0.2. This is our targeted value. Now just if we draw a diagram here, x 0, this can be 0.1, this can be 0.2. So because here it is not given that interval, the length of subinterval, what will be the length of subinterval? So if it was given just like this 0.1, then there will be 2 subinterval, and you have to do the process in 2 times. Then you can get the value at this. But here it is not given, so you can do it in single stage, taking what? H equals to 0.2 in single step. Then you can get direct this value. And you can also do this by dividing it as taking h equals to 0.1, then 2 step. First step do, and then second step also do by taking the value of first step. Okay, so here just we will use only single interval. Okay, for single interval, just just write what will be the formula for Runge's method. Runge's formula is what? Runge's formula is K1, K2, K3, K, and finally y1 equals to y0 plus K. This is the answer. What is K1? H fx0 y0. H f x0 plus half h half K1. H f0 plus h y0 plus K dash, where K dash equals to what? H f x0 plus h, y0 plus k1. And then finally, k equals to 1 by 6, k1 plus 4k2 plus k3. And finally, give the answer like this. These are the Runge's formula. Okay, so here in these questions, x0 equals to what? 0. y0 equals to what? 1. It is given. Na? This x0, this is y0. Clear? And fxy equals to x plus y, here given. And take h equals to 0.2, single interval. Okay, just this. And start by using this formula. Runge's formula is this. Therefore, k1 equals to h f x0 y0. That is h means 0.2. F x0 means what? 0. Y0 means what? 1. So equal to 0.2 into fx0 y0 means what? X plus y, 0 plus 1 equals to 0.2. So first value k1 equals to 0.2, kn equals to 0.200. Just use decimal places up to 3. Okay, now k2, h f x0 plus half h and half k1. So 0.2 into f x0 plus half h. x0 plus half h means 0 plus 0.2 upon 2 and half k1. k1 is what? k1 is 0.2. So 0.200 upon 2. This. So you can write 0.2 into f of what? 0.2, 0.1 and here 0.100. So this is equals to 0.2 into this x plus y format, f of this in this format. So 0.1 plus 0.100. So this is equals to 0.2 into 0.200. So this is equals to 2 into 2 into 4, 0.4240. 0.2 by 2, h by 2, h equals to what? 0.2. So 0.1. Here also 0.1. So 0.1 plus 0.1, 0.2, 0.1. Sorry, here y0 plus this in this formula, just we have to write y0 plus half k1. So y0 plus half k1. Here y0 plus half k1. y0 plus half k1. Okay, y0 plus half k1. y0 plus half k1. So y0 means what? 1. So 1 plus half k1, 0.200 by 2. This. So here value is what? 1.100. This. 1.100. So this is what? 1.200. So 240. 0.240. This is 0.240. So formula is correctly clear. y0 plus half k1. Okay, y0 plus half k1. So this is k2. Now k3. K3 can be found. Before k3, just you have to calculate k1. Okay. Now k1 equals to, sorry, just write 0.240. Okay. Now K dash equals to this H F x0 plus H and y0 plus K1. Okay, so H means 0.2, F of x0 means 0 plus H means 0.2, y0 means 1 plus K1. K1 is what? 0.20, 0.200. So this 0.2 F of this, just do it. 0.2, 1.200. You can use 0.2 and format is this x plus y. So 0.2 plus 1.200. Okay. So this is equals to 0.2 into 1.4, 1.400. So this is equals to what? 280. 0.2, 1.2. 0.2, 1.2. So we can get 0.280. This is equals to 0.280. This is value of K dash. K dash. Now this K dash is used in K3 for finding the value of K3. So here just use formula K1 is equals to what? We have got the values like this. K1 equals to 0.200. K2 equals to this 0.240. Now K3 equals to K dash. Also K dash equals to what? 0.280. Now K3 equals to formula H F x0 plus H, here y0 plus K dash. Okay, K dash, that is the formula, na? K dash. Okay, so just use this. K dash equals to 0.280. So this is equals to what? H 0.2, F of x0 means 0 plus H means 0.2 and y0 means 1 plus K dash. K dash equals to this 0.280. So 0.2 x plus y, 0.2 plus 1.280, and this is equals to, you can write the value of K3. Okay, 1.480, 1.28.1, here 0.1. So 1.28 1.280 to 1.4 by multiplying 296.296, we can get 0.296. 1.48 into 0.296. Okay, so just calculate it by using calculator. You can get the value. Okay, by same type of process. Okay, so this is K3. Okay, finally we have to compute the value of K. Clear? So K3 is what? 0.296. Clear? 0.296. Just we get K3 equals to 0.296. 0.296. Okay. So finally, So we get k equals to 1 by 6. Formula is what? K1 plus 4, K2 plus K3. This is our formula. Okay, so this is equals to 1 by 6 K1. K1 is what? 0.200 plus 4 into K2. K2 is what? 0.240 plus K3. K3 is this 0.296. This. Okay, now calculate it. You can get result. Okay, so 2426. 2426. 2426. This is the value of k. This is our final increment in y. That is y0 plus thus the required approximate value of y. Approximate value of y is y1 equals to y0 plus k 1 plus 0.2426, that is 1.2426. This is our answer. Okay, y1. Get it. 1.2426. Okay, this is simple method. Runge-Kutta method. This formula is, remember. Okay, first of all decide what is x0, what is y0, and then write the format from equation this and take value of h. If they here only single interval we consider, so one step we can get result. If two step, then two interval will be there. So at the first time formula will be for x0, 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 and for the next interval just you have to use just this formula by taking initial value y1, x1. x1 will be just end value of the first interval. Okay, so here x1, y1, x1, y1, x1, y1, x1, y1, xo, and so on. Here y2 equals to y1 plus k will be the answer, and x1, y1 will be previous value. Just this type of interval is there. Suppose this start from here. This is x0, y0. This is x1, y1. Just we have got y1. If another interval is there, then here y2, x2. So for getting y2, that is y1 plus k. And for this interval, initial value will be x1, y1. x1 means at this point value. Okay. So step by step we can do the calculation for Runge's method. Okay. So this is answer. This is the process of Runge's method. Clear? Now we will discuss about Runge-Kutta method. Okay. Now Runge-Kutta method. Okay. So Runge-Kutta method, just we have already studied about Runge-Kutta method. Already studied about Taylor series method. Just we have seen that by using Taylor series, we can get also the approximate value of y for our differential equations. What? dy upon dx equals to fxy, where x equals to x0, y equals to y0, and x equals to x0. This is our differential equation. And by Taylor, the first point is what? Our first point x0, y0 at x0, okay, at x0, and second point what? X1. That is here what will be the point? Y0, this point, and for this next point that will be the y1. That is point what? X1, y1. For approximation of y1, just if this is the step of interval h, then y1 equals to what? X0 plus x0 equals to what? X equal to here, x1 equal to this. That is y1 equals to what? Y of y at x1, that is y at x0 plus h. If initial value is given, then for the next, in one step at the end of this interval, that is the value of x1. At here at x1, the value of y is y1. Y1 can be get by what? Y1 means y at x1, y at x0 plus h. Y at x0 plus h, x0 plus h, y1. If we expand it by Taylor series, so then that what? Y at x0, that is y0 plus h upon 1 factorial, y dash 0 plus h square upon 2 factorial, y double dash 0 plus h cube upon 3 factorial, y triple dash 0, and so on. This is our Taylor series method. Okay, y1. So from here we see that for finding Taylor series, for calculation of the value of y1, we require what? Derivative of y. First order, second order, third order, that is the calculation of derivative. It depends on this format fxy. If fxy format is of typical type, then the derivative, finding derivatives will be very tedious. It is the heavy work. Okay. So there are also methods available that will not require the finding of any order derivatives. Only functional values may be used. Functional values means this is the given function or fxy. Just this is given function of any format. If we have 0, 1, then we can calculate it. 1, 2, we can calculate it. 3, 4, we can calculate it. That is the functional value. Only functional value. There are methods available which will use only functional values at some points, at some special points. Okay, just like Runge-Kutta method. The Runge-Kutta methods of different orders. These methods are available at different orders: first order, second order, third order, fourth order, fifth order. And all these methods agree with this Taylor series method. We can see just Euler's method, modified Euler's method, Runge's methods, all are available, all are involving in this method. Okay, here. Just take this first stage. Only this. So here we see that what? Y1 equals to Y0 plus H upon 1H, and Y0, Y dash 0 means what? Y dash means slope, derivative, that is this. At 0 means at x0. Okay, so what is this? Dash. This is, it can be written like this: y1 equals to y0 plus h f x0 y0. This is what? Euler's formula. Euler's formula. Euler's formula agree with Taylor's series up to the power h to the power 1. So h to the power 1, that is first order. First order Runge-Kutta method. Runge-Kutta method. Okay, RK method. You can say RK method. RK method. Okay. First order RK method. Euler's formula. Euler's method. Okay. If we take just like up to the power h or 2, then this formula is what? Just we can see that this formula is same as Euler's modified methods. After expanding this, we can get the similar formula. After expanding this portion, y1 equals to y0 plus h f dash x0 y0 plus h square by 2 y double dash 0 secondary y double dash 0. After expanding this, just also take what? y1 equals to y0 plus h by 2 average of fx0 y0 plus fx0 plus h x1 here x1 means x0 plus h and y1 previous value. This is Euler's modified formula. Euler's modified formula. It is agree with Taylor series up to the power h to the power 2. By expanding this, comparing these two, we can see that this formula is agree with Taylor series up to the power 2. That is second order RK method. Runge-Kutta method. Second order RK method means Euler's modified formula. And up to third order Runge's method. Just you can comparing, and you can see that the third order, up to the third order, we can get the formula for Runge-Kutta method. Okay, so third order RK method means Runge's method only. Okay, and up to the fourth order, h power 4 by 4 factorial y 4 dash at 0, up to the fourth order Runge-Kutta method. Fourth order Runge-Kutta method is main formula, because this fourth order Runge-Kutta method is known as only Runge-Kutta method. This is very, very important, and this gives more accurate value for the approximation of y. And for this, just note down the formula. Okay, for Runge-Kutta method. Runge-Kutta method means fourth order Runge-Kutta method. Only say Runge-Kutta method. For solving this, just here say as same to Runge's method. Just here K1, K2, K3, K4 is additional. Just we have to calculate this K1, K2, K3, K4 by using this format and this initial value, and finally we will compute the value of K. and finally answer will be y0 plus k. In an interval, if there are two intervals, then for the next interval, the initial value of the will be the just previous calculated value. Clear? So just write here formula for RK method formula. RK method formula. Okay, RK method formula. First of all, we have to calculate K1, then K2, then K3, then K4, then K, then approx value. Approx y equals to y0 plus k. This is our answer. Just in each step, in each sub-interval, you have to do this. If there is only single sub-interval, then just one time do this process. You can get approximate value of y. Okay? If there are 2, 3, 4 sub-intervals, then you have to do this process each time by taking initial value from the previous value. Okay? So here, K1. K1 is just same as Runge's method. Fxy is format. Here we know what is x0, what is y0, what is h, and what is fxy. These are, first of all, we have to decide this. Then you can use this formula. Okay? K2. K2 can be found by h f x0 plus h by 2 y0 plus half k1. This k1 is used here. x0 plus half h y0 plus half k2. This k2 is used here. H x0 plus h y0 plus k3. This is the formula. y0 plus k3, half k2. Okay. And finally, k equals to 1 by 6 k1 plus 2 times of k2, 2 times of k3, and k4 is single. This gives the value of k, and finally the answer will be this. This is Runge-Kutta method formula. Just remember this. Okay, and calculation is very simple, just like the previous questions. Okay, as Runge's formula, just you have to find the value of k1. First of all, decide x0, y0, h, fxy. If there is one interval, then just do one time. If there is two interval, then for the next interval, just you have to do same process by taking the initial value as previous value. Okay, so k1, k2, k3, k4, just we have to find and then use this value for finding the value of k, and finally approximation y is given by this. Okay, so take one questions from Runge-Kutta method. Okay, formula is very important, so note down this formula. Okay, so question is, apply Runge-Kutta method to find the approximate value of y for x equals to 0.2. For x equals to 0.2 in steps of 0.1. Here step is 0.1, but we have to find the value of y for x equals to 0.2, and the initial value of x is given 0. So 0 to 0.2, but the step is 0.1. So 0 to 0.1, 0.1 to 0.2. So our h equals to what? 0.1. So there will be two intervals. So two steps will be there. Okay. So here the given equation is solution. dy by dx equals to f xy what? x plus y square. X plus y square. dy by dx is equal to x plus y square. Given that y equals to 1, x equal to 0. Given that y equals to 1 when x equals to 0. This is given differential equation. And we have to approximate the value of y for x equals to 0.2 in step 1. Just remember this formula, okay? These are the formula for RK method, Runge-Kutta method, okay? We have to approximate, we have to find the approximation of y when x equals to 0.2 in a step of 0.1. That is the value, that is taking h equals to 0.1. That is here, if this, because here initial value of x is 0, so this is 0. If this is 0.2, this is 0.1. So this, there are two subintervals. So this is what? x0, y0. And here x1, y1. Here x2, y1, y2, y0, x2, y2. So for this interval we have to do the process first time, and we will get y1 equals to y0 plus k. And for next interval we will take, in place of x0, y0, x1, and we will get y2 equals to y1 plus k. That will be our answer for point 2. Clear? So here decide what? x0 equals to 0, y0 equals to 1, h equals to 0.1, fxy equals to x plus y square. These are the constant of x0, y0, h, this. Now, using RK method formula as K1. K1 equals to what? Same, x0, y0. H 0.1, f of x0 means what? 0. y0 means what? y, 1. So we can find 0.1 into x plus y0. X means 0 plus 1 square. So this is equals to what? 0.1. First value is 0.1. Here step 1. There will be two steps. Step 1. Step 1. Okay, you can write here using step 1 is this. First step. Okay, so 0.1 just write with decimal symbol, okay, for first step. Similar, K2. What is K2? H, F, x0 plus h by 2 and y0 plus half K1 half K. This is formula. Formula is very thin. Here x0. So H means 0.1. F of x0 plus half H 0.1 by 2. So 0 plus 0.1 by 2 and y0 means 1. 1 plus half of K1. K1 is this. Half of K1. 0.1 0 0 0. This can be solved. What will be the value for this step? First stage means in first subinterval. This is equals to 0.1 into 0.1 by 2, 0.5 f of just 0.05 1.1152. No, 0.05 1.11. 0.05 1.1. 1.1 half of K1. K1 is 0.1. 0.1 half. 0.5 into 0.1. One plus half K1. K1 means 0.1. 0.1 means 0.1 half. That is 1 upon this means 0.5 by 10. 0.05 into 1 plus 0.05. So 1 plus 0.05 will be there. Okay. One plus half K1 this, so 0.05. This can be calculated just like 0.1 this 0.05 plus y square 1.05 square. So you can solve it by calculator. So value will be 1152. 0.1152. 0.1152. So find the value of K2 just like this. Okay. Here K3. HF x0 plus h by 2 y0 plus half K2. Here K2. Okay. K2. Just 0.1. Here we can see that this is equals to 0.1 f of x0 plus h by 2 same value 0.05 and y half K2 y0 means 1 plus 0.1152 this. Okay, 1.1152. So 0.1 into f 0.05 1.1152 0.1 this formula is used. 0.05 plus 1.1152 square. Just you can use calculator and can calculate this value just like 0.1793. 0.1793. This is K3. Now we have to calculate K4. Okay. So main thing is this formula, just remember, okay? K1, K2, K3. So K1 is this, K2 is this is K1. This is K1, this is K2. Now K3 is equals to what? 0.1793. Okay. Now find the value of K4. Here K4 is also we have to find. So K4 is the formula for K4. K4 equals to HF X0 plus H Y0 plus K3. This is the formula for K4. Okay, for K4. Just this is formula. Now use this 0.1 f of x0 plus h. x0 0, h means 0 plus 0.1, and here y0 1 plus k3 0.1793. So just like this. Okay, 17. K3 is equals to 1168. 1168, sorry, this is 1168. 1168. This was the 1168. Okay. Now here 1168. 1168. So 0.1, and just here we see that 0.1 and 1.1168. 0.1 plus this plus square 1.1168 square. This can be calculated. 0.1 plus 0.1 plus this square 1347. 1347. 0.1347. This is K4. Just use formula, just calculate from yourself by using calculator. You can get the value. Okay. First value is 0.1000, second value 1.152, third value 1168, 1347. K4 is 1347. Now we have to find the value of K by using this value. Okay. So after getting these values, we can use finally K is equals to what? 1 by 6 K1 plus 2 K2 plus 2 K3 plus K4. 1 by 6 K1 means 0.1000 plus 2 times of 0.1152 plus 2 times of 0.1168 plus 0.1347. 0.1347. This is the value. Okay, by using just K1, K2, K3, K4. Okay, 1347 and 2 times of this. Just you have to calculate it by using your calculator. Just multiply it and add and divide by 6. You can get 0.1165. 0.1165 K. So we get the approximation of y for x equals to 0.1 for first step, 0.1 and 0.2. Two steps are there. Okay, so just like this, na? Here 0, 0. Here x1, 0.1. Here x2, 0.2. So at here x1, this, that is y 0.1 is equals to as y0 plus k, that is y0 means 1 plus this 0.1165, that is 1.1165. This is y 0.1, y1 equals to y x1. This is for x equals to x1 equals to this. Clear? Y for x equals to x1 equals to 0.1. So y1 for next test is y1. This is the approximation 1.1165. Now our when x equals to 0.2, step 0.1. So next interval, for this interval, just repeat this process and taking initial value as 1, 1. Just formula will change, simply change. Now step 2. Step 2. Okay. (1.1162). Step second. Here x 1 equals to 0.1, y1 equals to this value 1.1165. For first interval x0 y0 was the initial value. For second interval, this is the initial value. And fx equals to same. Fx equals to fxy equals to x plus y. And h equals to 0.1. Therefore, q1 equals to h f x1 y1. Now x1 y1 will be used. Clear? x1 y1 will be used. Clear? So here x1 means what? x0 plus. x0 is 0. So 0 plus this. You can write like this. Here x1 equals to x0 plus h. We will get like this. 0 plus 0.1 equals to this. And y1 equals to, we got it, 1.1165. But these are the initial value. Now just calculate. H means 0.1, f x1 means 0.1, and y1 means this 1.1165. 0.1 plus 1.1165 square, and you can calculate it. Okay, 0.1, 1.68, 1347, 0.1347, 0.1347. Just use calculator, you can do it. Clear? This is K1. Okay, K1 is equals to what? 0.1347. Now K2. K2 equals to, what will be the formula? H, F, formula will be just like this, x1 plus half h and y1 plus half k1. K1 is this. So you can get like this, 0.1 into f of x1 plus half h. x1 is what? 0.1. 0.1 plus 0.1 by 2. 0.1 plus 0.1 by 2. And y1 is this, what? 1.1165 plus half k1, half of 0.1347. Okay, this, and you can also calculate it. 0.1, just do it by using calculator. This divided by this, finally this divided by this plus this, x, y, use this formula, y square, okay. And you can get value as 0.1551. 0.1551. Just note down, because formula is main thing. Similarly, K3, H, F, here for this stage, initial value x1 value. This. So x1 plus half h, y1 plus half k2. Use this, you can get the value. Just put here value. K2 this, y1 this, h 0.1, x1 this. Just put here and use this formula and multiply. You can get K3 as 0.1576. 0.1576. Similarly, K4 will be formula what? H, F, x1 plus h, y1 plus h. This x1 plus h, y1 plus K3. Okay, so use K3, this value, y1 is this, x1 is also this, h, you know. So you can calculate it also. Just calculate by using calculator. 0.1823. 0.1823. So these are the K1, K2, K3, K4. K1 this, K2 this, K3 this, K4 this. Numerical methods. That's why numerically you have to use your calculator and calculate these values. Formula is main thing. Okay, this, and just use value step by step. So K1, K2, K3, K4 I give. We have find out, and now finally K. Finally K equals to, finally increment in y is K equals to 1 by 6, K1 plus 2, K2 plus 2, K3 plus K4. Just use all these values. 1 by 6, K1, 0.1347 plus K2 2 times of 0.1551 plus 2 times K3 is this 1576 1576 and finally K3 1823 1823 plus 1823 this. Okay, you can calculate. By using calculator and get what is the value? 0.1571. 0.1571. This is it. Okay. Thus, the required approximation of y is y2 equals to y, x2 equals to y, point 2 equals to y1 plus k. Okay, y1 plus k. y1 means this 1.1165 plus k is this 1571. 0.1571 1571 1.2736 1.2736 clear 1.2736 1.2736 this is approximation at here okay, so this is the solution in 2 step. If there is single interval, then single time processing you can get the value of y. Okay, so this is the process of finding the approximation of y by using Runge-Kutta method, RK method. Okay, now just you have to do 2 questions for your attendance, one from Runge methods and second from Runge-Kutta methods. Okay, just use formula step by step. If there is single interval, then you have to do one time. In one step you can get the result. If there is 2 or 3 steps, then 2 or 3 times you have to calculate all the values and finally find the values of y, approximated value of y. Okay, so Runge-Kutta method and Runge's methods, just like same process is there. Okay, Runge's method, Runge's formula and Runge's Kutta formula. Just remember, formula is main thing. For differential equation, dy by dx, fx plus fxy is function and x equals to x0 or y equals to y0 or at x equals to x0. This is condition. At x equals to x0. This is x0, this is y0. Initial value. Format fxy. And step h may be given, may not be given. Depend on the type of questions. Okay, so just find it. And then use formula by using this. In the first interval, just find value of k1, k2, k3 and k, and finally value of y equals to y0 plus k. This is final answer. Clear? So finding the value of k1, k2, k3. Just I repeat one time formula. Very simple formula. k1 h f x0 y0. k2 h f x0 plus half h y0 plus half k1. Just write formula for 5 times, then you can remember it very easily. x0 plus x0, y0, x0 plus half h, x0 plus h. k3, here k1 is used. Now for k3, h, f, x0 plus h and y0 plus k dash. K dash is what? K dash is used as f, x0 plus h, y0 plus k1. By using this, you can get the Runge's formula. Okay. y0 plus k1. Very clear. Okay. Now k1, k2, k3. Therefore, k equals to what? 1 by 6. k1 plus 4 times of k2 plus k3. This is the value of increment in y. Therefore, y1 equals to y0 plus k. This is our answer. So you can write k is main thing. K. For k, you have to calculate this quantity. First of all, find k dash, then use this k dash here. Then you can get the value of k3. The first step, k1, k2, then k dash, and then k3. And for Runge-Kutta formula, here also using start k1 h f x0 y0, k2 h f x0 plus half h y0 plus half k1. Just use this k1 here. And k3 is same type of formula, x0 plus half h y0 plus half k2. And k4 is equals to h f x0 plus h y0 plus k3. Therefore, k equals to what? 1 by 6 k1 plus 2k2 2k3 plus k4. This is the value of k. Thus, y1 equals to y0 plus k is answer. Clear? So these are the formula. Just calculate as in the previous questions. Okay. So here formula is x0 plus h, y0 plus k3 is there. Na? K3. Okay. K equals to this. So by using this formula, just solve these two questions and send me for your attendance PDF file. Okay.